How's it going, geometry class? Today we are looking at 6.5, conditions for rhombuses, rectangles, and squares. Oh my, again? Well, here we go, guys. Let's just jump into it. Remember how, well, anyway, same theorems as before, just the opposite, okay? So what do I mean by that? Now we're going to be given a parallelogram, and we say that the diagonals are perpendicular. If the diagonals are perpendicular, then the parallelogram is a rhombus. It has 4 equal sides. Okay? Any questions? Just raise your hand. I'll call on you. That's a joke. That's a joke. Next slide. Oh, theorems up the wazoo. Next one. Same thing that we've seen before, guys. If we have a parallelogram and it bisects a pair of opposite angles, cuts them in half, then the parallelogram is a rhombus. Okay, so if it cuts this angle B into 2 equal angles and D into 2 equal angles, then ABCD is not just the first 4 letters in the alphabet, but it's also a parallelogram. Okay? And last theorem, I think, of the section. If I'm wrong, I'll eat my hat. I don't wear hats, but I would. If we have a parallelogram and the diagonals are congruent, then it's a rectangle, okay? Now remember, a square is like the baby of a rhombus and a rectangle. So all these theorems hold true for squares. It's a rhombus and could be, because a square is a rhombus. And could be because remember, a square has 4 equal sides, so it makes it a rhombus. But not all rhombuses are squares. A square also has 4 right angles, which makes it a rectangle. But not all rectangles are squares. Okay? So if a theorem holds true for a rhombus, it holds true for a square. If a theorem holds true for a rectangle, it also holds true for a square. Okay? A parallelogram has angle measures of 20, 160, 20, and 160. Could it be a rhombus, a rectangle, or a square? Let me just do a quick sketch. Say that's 20, 20, 160, 160. Well, the angles aren't 90 degrees, so it can't be. It's a 1A, by the way. Can't be a square because it's too cool, or a rectangle since no right angles. Okay, but now the way I drew it, it's not, doesn't look like a rhombus. But could I shrink these sides? Could I take this and I drew it all as one piece? Anyway, could I go, let's say connect these 2 parts? I could. So it could be a rhombus since opposite angles are congruent. Okay. 1B. Suppose the diagonals of a quadrilateral bisect each other. Could be a rhombus, a rectangle, or a square. Ready? All of them. Since they're all parallelogram. Since all parallelograms have bisecting diagonals. Okay? Woo! Got a joke for you if you're writing. It's been a while. How long does it take for a gymnast to get to class? A split second. Oh, even I'm not impressed by that one. For what value of y in D, E, F, G is this a rectangle? Remember, a rectangle has congruent diagonals, and they bisect each other, so all the pieces are congruent. Okay? If all those are congruent, I can just set these equal to each other. Okay? Add my 5. 5y plus 8 equals 7y. Subtract 5y. Subtract 5y. 8 equals 2y. Divide by 2. Divide by 2. 4 equals y. Bada boom, bada bing. Builders use properties of diagonals to square up rectangular shapes like building frames and playing field boundaries. Suppose you are on a volunteer building team at the right. You are helping lay a rectangular patio for a youth center. How can you use properties of diagonals to locate the 4 corners? Ready, guys? I want you to think about this one. Bring in your idea to class. You have to bring in an idea. Okay? When I come around and check notes, I'm going to look for an idea. It doesn't have to be right, but give me your best idea and we'll talk about it in class. Okay? What's this slide? I thought it would be blank. Look, it's a polar bear in a snowstorm. I'm sorry. Okay. Which special parallelograms have the property of diagonals are perpendicular? Well, if we look back, we can see that rhombuses do. Now remember, if a rhombus does, so does a square. Okay? Alright, now which one had congruent diagonals? Oh look, it's a rectangle. And if it could be a rectangle, that means it could also be a square. Diagonals are angle bisectors. Let's see if we have any theorem like that. Bisects opposite angles, then it is a rhombus. So rhombus. And if it's a rhombus, it could also be a square. Diagonals bisect each other. That is all parallelograms, guys. So all 3. Diagonals are perpendicular bisectors of each other. Well, let's see if there's a theorem for it. What's this? Perpendicular, and they bisect. That would be all rhombuses. And squares. Okay, that's all, guys. Make sure you do that one thinking problem, and I'll see you later.